Good day, folks. Here it is, self-looping. It's charging right now. I got it set to the this one here is set to the two set of capacitors over here, and then I'm just tapping into one for the trigger, pulsing it with the controller. If you understand, that could be a 555 that could run on one of the capacitors as well. And I just wanted to show you the steady increase in voltage here because we're getting close to 100 volts of output here. I got the one wire system, tapping on one of them, sending it back to the capacitors. So I only have one out of all of these capacitors actually triggering it. And with the one wire system, the super high voltage, and of course I got the ground on one of the wires here. And as you saw in my previous video, almost 200 volts. So yeah, that's really moving those capacitors, as you can see. And it's just the controller right now. This could be self-sustained, much simpler. You could use a 555 timer, I'm sure, for even better methods, but it's just to show you the concept here real quickly. But as far as those capacitors are concerned, there's more energy coming in than coming out. And the meter's connected to the capacitors, and they're charging pretty quick, considering these are supercapacitors. I mean, I just want to show you the simple self-loop setup with capacitors and the earth ground and using pure potential, because we don't need very much to trigger it, right? I mean, so I'm only tapping into one capacitor, so maybe I'd like half a volt to 1 volt is pulsing and triggering this whole coil at very high frequency here thanks to the switch, and this is what we're getting in return. And all we're doing is pulsing it to ground and using the one wire system to feed it back into the set of capacitors here, continuously re-gauging itself. So I'm not sure if this is the loop some people were talking about that they wanted to see. We still see it. It's been 3 minutes now and there's still an increase in gains. And I'm not playing any silly games. Here it is. The capacitor is the input and the output. The only thing the switch is doing is pulsing the cap at 3% through the coil, and it's generating all that radiant energy. We're converting with the one wire system. We can do that because it's one wire. It's a separate loop on one wire, so it's totally isolated from the input pulse. And people were blaming me in the past, oh, you're exploiting the lead acid anomalies. That wouldn't happen after a few minutes. Well, we're eliminating the battery here completely as far as input and output goes. The switching runs on peanuts, we all know that. You can run an earth battery or anything you want to trigger a little chip to do this. You could probably even use the environment to switch it for free if you're clever. So again, don't pick on the switching here. I'm talking to you about the capacitor input and output, because we're limiting with the switch very low duty cycle and only one cap out of the set just to trigger. We separate the current from the potential. We leave the current alone. We increase the potential. We hit it against ground. That amplifies the difference or creates more of one. We use the one wire system. We send it back into a set of capacitors. And on one of these wires will not do anything, but we could charge an auxiliary 9-volt battery, which essentially you would loop back and forth if you wanted to, and that would actually run your controller. So there you go as far as the controller is concerned. Initially, you're going to have one charged battery, but with this kind of setup, folks, if you understand what I'm getting at, once you get it going, you've got an independent loop going on. So as long as you time it correctly, you'll be able to run off the same sets of 9-volt batteries, for example, that runs the switch and charges, that uses these caps here. See, the caps likes to charge a lot easier than batteries, so it just makes more sense to use caps. They're lower resistance as well, so you don't have to fight with it as much. It's not like going such steep uphill. So 5 minutes now, and we're still doing a nice increase. If you don't believe the voltage I was getting, it's the same setup. Just go to my previous video and you'll see this thing jump almost to 200 volts with basically no input trigger. And I was trying to say that you can loop it. I don't know if I got across properly, but this should clarify it hopefully. So again, like I said, you can have a 9-volt battery charging off of one wire system, and when that's ready, that runs the switch controller, and while it's charging another one, so you always have a dual set flip-flopping. You'll never run out. Because we're using pure potential differences and converting that back into capacitors, into traditional current. We're just not using it all on the fly here. The switch is limiting it. It's gating it so it goes back and stays in the capacitor. Now we're at 7.09. So this is pretty neat, folks. It's a pretty quick charge. And remember, this is not a normal, these are super caps, 2,000 farads each, rated at 2.7 volts. I got them chained up to be able to handle up to 14 or so. But this is like simulating battery cells, and I could individually tap into every cell I want. So that's how I'm only getting the first cap, which is about maybe, I don't know, a volt. And it's triggering the system and then charging itself. And I'm sorry if I'm repeating myself here. I just want to show everyone what's going on in the continuous charge up. And all we're doing is using the ground to amplify this effect. So this isn't running right now. It needs to trigger by another battery here. It's just on the circuit board. I'm just using the switch to pulse the capacitors. It's 7.093 now. The reason I thought of this is that over there I got a half-dead 1.5 volt battery, and I tried using that as the pulse trigger, and I got a lot of voltage. I said, you know what, maybe it'll work in as an individual capacitor bank. So I tried that, and sure enough, it's doing the job. So yes, capacitors I think play a big role in this kind of a setup, in a way of either keeping it in the capacitor or transducing it with the capacitor or dumping it with the capacitor. The capacitor is that device in between the potential differences, the one-wire system that many argue can't be any useful work, but it obviously is once it hits the capacitor, right? So there's the one of the key. There it is right now, the input and output to the switch. So again, think of this in the context that it's charging an auxiliary 9-volt battery on one of these while running off the one you charged before. So what I'm getting at is you'd only have to charge it once traditionally, and then from that point the set, you can just rotate them. So this is kind of like a Bedini setup, but maybe done more appropriately. I wouldn't say it's inappropriate the way Bedini did things, but it's taking the whole idea and making something better out of it. So again, the 2 for the price of 1 pretty well applies here as well, as far as recharging batteries and capacitors, as you can see. This takes me a few amps because it's a supercapacitors to charge up, but with this setup here, it's just taking it. And it takes me about 20 minutes to charge them up with like a 5 amp or so 12 volt supply. So this is pretty significant rise. The supercapacitors, even though they're super, they're acting like regular capacitors to this kind of energy, and doing, I guess because they've got so much capacitance, is doing a good job at converting that back to something. And once this is charged, because it's super capacitors, if you put a voltage regulator on this thing, it'll run a small stereo for half an hour to 1 hour. So you could really get some serious power out of them, and much more efficient than dumping it into a battery here. See, in theory, if you had enough of them, you can stack them up to gain on the current, and you can run a regular inverter on there. And that could be running everything on pretty well in your household. Assuming you have all the storage, you'll need more than a few capacitors for that, but it'll work on the same concept. So yes, all of this is scalable, highly scalable actually. And not too costly. Well, everything's a cost, but you're not talking about millions of dollars here. And this is becoming easier and easier to reproduce, which is what I like, folks. I'm trying to find something that, doesn't require to be a expert in whatever, I'm so far the way this is going, I might be able to start into the direction of maybe providing online only, but like guides and kits and whatnot on how to get this going pretty easy. So 7.1 now. And remember, we're loading these. It's initiating the trigger and self-charging, but it's not a closed loop. It's not a closed loop. And this is what happens. We split with the oscillator, which is the switching here. We send the difference of high frequency to ground. And this is the pure potential that hits the capacitors, and the capacitor transduces that back to regular energy. It's just the supercapacitors, you know, and enhance the effect. Because when we're going to load this with, let's say, a regular inverter or a motor or whatever, you're not going to go to zero within 2-3 seconds. It's going to run maybe for half an hour or more. So this is what I mean by a lot of storage. They're more like a small battery. And the more of these you have, the more battery-like on the output. The VI curve resembles that more of a battery under a load than the discharging capacitor. So 16 minutes now, and we're still charging pretty good. So I think I'm going to close it at that, and I hope you enjoy, and let me know your comments as always. And thank you for watching.